Hi, everybody. I'm Thomas Davis, a lead researcher here at Monsters, Aliens, Robots, and Zombies. From now on, I'll call it MARZ, but I always like the name because it's fun. As you might have guessed from the name and this title screen, MARZ is a VFX company. But if you ask our marketing team, MARZ is an AI technology startup and VFX studio on a mission to help Hollywood studios push creative boundaries and solve the systemic and growing challenges facing the entertainment industry today. So really, we're a VFX studio that has started to foray into AI tools to really just address some of the capacity constraints that exist in VFX today and the capacity constraints that we've all heard a ton of about in the industry. So just some cool slides, some of the things that we actually work on here at MARZ. As a company, we've worked on some very cool projects like Thing from Netflix's new Wednesday Addams series. And this was one where we actually received the greatest compliment of a VFX firm, where everybody actually thought this was practically shot. So practically shot as in an actor was there and acting out every single scene. But in reality, each one of these, for the harder shots, were actually modeled, textured, animated, and integrated entirely by MARZ. So there was the practical actor for some, but for a lot of the harder shots, MARZ was responsible. Another one that you may have seen us on is Moon Knight. Where we worked on the cape and its interaction with the surroundings. Sadly, these are kind of the last of the cool videos. I don't actually work on these projects, but I wanted to give context of our company as a whole, and I think they're really cool. So you might be asking, why am I actually here? It's not to show these cool visuals. Well, in general, our company has kind of two categories of solutions in our portfolio. One is core VFX, and the other is Vanity AI. Today, I'll really be talking about Vanity AI. I'm sorry because you won't see any more of those cool visuals, but luckily, we're really excited to show what we've been working on and what we've built over the past few years. First, why is a VFX company building ML tools? And in short, there really are fewer artists, higher demand, and a sustaining level of quality being required by Hollywood. So last year, to give some numbers, television released 593 new series, with over 27% growth rates from previous years. Spend is over $100 billion. And in general, people expect and want more spectacles. They want dragons, they want explosions, they want realistic hand motion like in Wednesday. And they want this at Hollywood quality. No longer can TV be at a lower grade. So all of this is really just to say that we need to be able to do this work faster and we need to be able to do it cheaper for these industries to scale. So in general, like a ton of AI companies or startups, we are trying to democratize VFX. So what does that actually mean for MARZ? As a leading AI-enabled technology organization, we're really just investing heavily in creating solutions that exceed four specific requirements. So as I said, we want to be able to produce feature film quality VFX, so we can't compromise on the quality. We want to be able to offer it at affordable pricing, and we want to execute these on the rapid timelines required for these studios. Finally, we need to be able to do this on demand without constraints and without making concessions. So overall, our mission is to enable production with Hollywood content on TV timelines. And really what I'm presenting today is that we're building AI tools to get us there. So the tool that I'll be talking about today is Vanity AI. We just released it publicly, I think maybe 2 months ago. When you guys see this. Vanity AI in general is a production-ready solution that empowers VFX teams and Hollywood in general to deliver large volumes of high-end 2D aging, de-aging, cosmetic, wig, and prosthetic fixes. In general, really what we're offering here is a tool that can do this work on average 300 times faster than traditional VFX pipelines at a significantly better cost. And with no real capacity constraints. So previous work is always limited by how many artists are available and what is the timeline and budget of the project. By using ML, we're able to bypass this capacity constraint. So in layman terms, our tool makes it really, really easy to produce shots like this one for cheaper and faster than before. So what we're actually seeing here is the original actor with wrinkles and some eye bags, and you can see the chin line as well. And to make them look younger, we are bringing those in, smoothing out wrinkles to essentially achieve the look desired by the studio. In general, what does Vanity AI do? Well, faces are extremely complex. These are just some of the edits that are required, or some of the features of a face that actually give a person an indication of age. So what our brain picks up on how we identify the age of a person. And in general, Vanity AI tasks can be as simple as just removing eye bags and a few shots because someone didn't sleep well before the shoot, or they can be as complex as the one we saw before, where we're actually doing a 20-year de-age, targeting essentially all of the features here. So Vanity AI can actually be used for either just simple wig fixes, where we want to bring that a wig line that's visible in some shots out, or eye bags, and can also be targeted to do a full de-age, like Benjamin Button style. So first, I wanted to give a little bit of context on how it's done today, because I think it shows you why this solution is so important and needed for de-aging beauty fixes to scale. So essentially, vanity work today is extremely cumbersome and a very manual process. What we see happening here is that the artist is actually tracking key points on the face as a method of tracking edits that they then make to regions of the face. So for each region being edited, whether it's eye bags, laugh lines, nasolabial folds, you kind of get the point. A mask has to be created. So for every single region of edit, you create a mask. Then within each one of these regions, you're essentially building a series of image manipulations that then target the desired look within that region. So these are things like blur, retexturing, changing the color. And what we see is that the artist is creating these polygons manually, tracking them from frame to frame. And then for the rest of this 2-minute video, which is sped up, I think like 10 times, they're actually just tweaking that tracking, tweaking the regions that they're editing, and ensuring that all the edits that they apply are actually temporally consistent throughout the shot. And so, as you can see, artists have complete control over the flow today with very advanced tools that allow them to do what's called rotoscoping and apply the edits to those regions. But it's still a very manual process. And on a shot like this, it actually takes them about over 3 days to do this work. And you can see here the before and after, which is pretty cool. So one of the big benefits of actually working at MARZ is that we get to understand exactly the workflows that artists go through today and work directly with them to try to optimize and speed up those workflows. So we can benchmark performance, interview our customers, because they're actually within the company, and gather requirements on our products just by going into the office for the day. Now that we understand the actual work that goes into a single shot, the thing to keep in mind is that that exact same look now needs to be applied to all shots of that character across the entire film. So once the look development is actually done, a simple de-age beauty or wig fix job typically actually contains anywhere from 20 to 50 shots. So essentially, we're asking artists to do this 200 times more. And the key detail here is that they actually start from scratch every time. So although you've done the look development on a single shot, the client has approved that single shot, there is no mechanism in tools today that actually allow you to apply that change to other shots. So this problem is really what motivated the creation of Vanity AI. And in general, artists don't mind creating the look development shot. It's a fun job. It's the actual art. They get to work with the client, achieve that desired look, revise, repeat, and basically really refine what does someone who's 20 years younger look like, and how does the client want them to look. However, then taking that approved look and applying it to 200 more shots is just tiring. So really our goal of building Vanity AI is to allow artists to focus on the art they enjoy while automating some of the repetitive work that they would really rather not be doing. So luckily, all the previous shows using traditional methods that MARZ has worked on weren't for nothing. So they actually give us extremely rich data in the form of before and after tuples. So you can see this kind of image here that shows us the example of kind of an input and what we expect as output. And we have this for example, for this show, we have that exact same edit applied to 250 shots. And as we all know, problem-specific ground truth data is really just gold for ML. This is exactly what we want to be able to work with. And it gets even better than that, in that we actually have this data for all of the shows that we have worked on historically. So this is really, when I joined, kind of like a gold rush of data, where not only do we have for every single edit 250 clips, each with 500 frames, for example, we also have the 30 or so shows that we have actually previously worked on and got permission to use as training data. So really, all this artist pain not only identified Vanity AI as the product that we should build, but it also gave us the resources to build it. So I wanted to start off by showing the new Vanity AI interface. This is a demo interface, so keep that in mind. But in this example, what we're seeing is an artist performing a general de-age job. So they are removing laugh lines, eye bags, and wrinkles throughout the face. We see how artists are able to control the output by interacting with the various sliders, controlling the blend strength, edit strength, bringing back and removing textures. And then just like we saw in the traditional flow, artists are then able to apply masks and localize edits to specific regions. So when they play with those sliders, you then see the edits only applied in those regions. And all this is to say that artists in our new design are still in control of the output. We're not telling them what results specifically to choose, but letting them use Vanity AI as a tool to produce their results faster. So you might be asking, this looks just as complicated as the traditional flow that we showed, but the difference here is that when an artist edits a single frame, those changes are actually propagated to all other frames within the shot. And further, those changes on a single frame in a shot are propagated to all shots that we have of that identity. So no longer are you just wasting work on a single shot. You're actually editing a single shot and seeing those changes applied to all shots within a collection. So instead of being asked to apply the same edit 200 times, you're doing it once and simply tweaking and verifying the results. So we see this as artists are essentially able to elevate themselves above to be able to work only on the art, so the look development and the actual defining of the look for the client, while Vanity AI then is able to apply those changes to all other shots within the collection. So you can just imagine the time savings that come from this. And so now I'm just going to show all of the results that I showed before, but with the context of these are actually generated from this scheme. So a single frame is edited and the changes are propagated to the rest of the shot and other shots within the set. And I'll show just one other show to prove that we do actually work in different de-aging tasks, not just on that one character. So I did want to actually loop in weights and bias a little bit because it has been a really important tool for us here at MARZ. So I'll talk a little bit about that. And sorry in advance because I recently found out about this new cutout people feature in PowerPoint, and I'm a little bit obsessed with it. So you'll see this guy throughout the slides. But in general, pretty early on in Vanity research, so we've been working on this for about 3 years now. I joined a year ago, but in general, we were producing results that we thought were really pretty awesome. So those videos that I showed, we were producing things like that, and we thought from the data we were given, we were producing results that looked almost identical to the target in our eyes. So we were pretty excited. And as I said earlier, one of the most valuable aspects of a tool like this being built by a VFX firm for VFX artists is that we are able to gather requirements and get feedback really, really quickly. So once we were able to produce results on the data that we were given, we immediately sent them over to the artists. And the artists thought they were not that great. So in general, this was one of the findings of our kind of feedback loop is we really did have to share things with artists quickly, get feedback very quickly, and integrate it as fast as we can. So in reality, the artists didn't actually say, that looks like crap. They said, these are good and promising, but. And this is kind of the first thing that we as researchers encountered is that the researchers and the VFX artists really don't have a common language. We understood the requirements from a research side, they understand it from a VFX side, and by integrating us into this feedback loop, we were starting to actually understand what it meant to produce content for Hollywood. And in general, we knew very little about this, but artists knew them all too well. They knew about the struggle of working with clients' requirements, producing content at the level of fidelity that clients require. And in these early days of research, our feedback loop was really focused on just identifying the core pillars of any minimum viable product for us to build. That introduces the three pillars. The first is any method that we build has to support any resolution. So this really just means that whatever the input resolution is, whether it be 4K or 16K, which is surprisingly and frustratingly common now, our method needs to be able to support that higher resolution. And you may notice that there really aren't a whole lot of models, especially off the shelf, that support this high resolution. So, for example, models like StyleGAN, trained on FFHQ, are pretty much limited to the 1024 by 1024. When you think of 16K resolution, you're entering a whole other beast of problem. And the amount of data in that space is pretty limited. So one lucky thing that we had was that we did actually have all of the data. So we have this historical backlog of 30 shows that we had worked on, and we're building more as we went. And for every single one of those shows, we had all of the content within them. So all the faces, all the characters, and the before and after edits. So luckily, we were able to identify this quickly as a requirement and start to curate our data to be able to build a product that met that requirement. The next pillar is localized edits. So this is a very frustrating requirement for VFX. And in general, we can think of it as if you are tasked with editing the eye bags of a character, then any change outside of what we expect eye bags to be is an immediate reject by the client or the supervisor. So the idea is that edits really have to be localized to the region of interest. And when you think of all the results coming out with DALL-E and Stable Diffusion, they are a lot more stable than they used to be temporarily, but when you think of where those edits are actually happening, they're often all across the image. And in a context of Hollywood, they need those edits to be extremely localized just to the region of interest. And this is just due to all the additional layering and effects that will go on top of just the beauty or DH fix. So it is quite a hard requirement. And historically, artists solved this with very tight rotoscoping and manual tracking from frame to frame. And we really extended this by allowing the projection of masks on one frame to all others. So we targeted this problem by basically speeding up the flow of localizing edits to a specific region. Then additionally, just by applying thresholding and improving the model's capacity to localize edits, we also improved on this a lot. So then the final pillar, which I think is a really important one and one that's often overlooked, is really just this idea of artistic control. So we didn't want to build a product that you entered remove eye bags and you got an image out, because in reality, it's not as cut and dry as that. So generally, even simple edits like removing a pimple have creative direction. So if you have a character and they have 50 pimples on their face and they want them removed, they might not actually want all of them removed. They might just want some of them toned down, or they might want to be maintaining consistency from a shot in which they had better skincare that day. So it's an interesting problem of really there is no ability to just say, do this and give me a result. The artist does need creative control. And in general, our focus was just, we don't want to take away the ability for artists to have control. We just want to allow them to get to what they want faster. So in general, one-shot models that produce something that an artist has to take are very rarely useful in a creative setting. So now with all these pillars in mind, we were able to design an architecture that supported any resolution, enforced edit localization through the mask propagation, and improved model architecture. And then finally, we didn't wrestle control from the artist. So we really allowed them to work with Vanity AI as opposed to be told exactly what to do and lose their freedom. So now, once again, we were happy and we were sure that these results were ready for the big screen. Unfortunately, once again, our feedback was that there was quite a few issues once again. So this was our kind of second hurdle of really trying to understand the minutia of what VFX artists look for. So these artists are so good at looking at a shot and pinpointing errors at the pixel level. So in our first real review back with artists after building on those core pillars, is we got all these comments like softness on frame 1082, color shift in the eye bags, texture popping throughout. And for anyone in VFX, these are probably very familiar terms, But for someone in research, and especially for myself coming from a CAD background, these terms were completely foreign. So really what we then did was focus on understanding what is the mapping of these terms in VFX to kind of common ML terms that we are familiar with. So we were able to then focus on softness is color matching, texture popping is temporal consistency, ghosting artifacts is edit localization, and really try to pinpoint and define what are the qualitative metrics and measures that map to these specific issues. And this was also a really good time for us because it's when we actually were introduced to weights and biases. So what this allowed us to do is once we had these metrics and we were able to define them well, then we were able to run these experiments and evaluate their performance against huge sets of shots. So we were actually able to, for all of those 30 shows and each one having 200 shots, we were able to actually run experiments against all of them, track all of our metrics, and really focus the artist time on which shots to be reviewing and giving us feedback on. And then additionally, we were able to allow researchers to use the metrics to target shots for follow-up experiments. So we were able to identify these are the shots that have temporal inconsistencies, these are the shots that have softness issues, these are the shots that are under editing, and really start to come up with a principled approach of how we should actually be solving these problems. And I always love these visuals, but in general, we ran countless experiments comparing the per frame performance across all shots in our library to further refine our understanding of what a bad shot was. So this visual essentially just shows 4 different shots and then the per frame metrics that we measured. So in this case, I'm just showing one of the metrics, which is edit pixel error, which is a pretty simple one of what is the error of each pixel across the region that we're interested in. And what we can actually see is you can see that temporarily, as the shot goes on, we have varying levels of error. So when we would then give these shots as review for artists, we were actually able to pinpoint specific areas that we thought in the metrics correlated to their comments. So the artist would say things like, oh, on frame 1090, the eye bag edit disappears. We would be able to look at the per frame metrics that Weights and Bias produced and actually correlate them to further refine our ability to actually detect a bad shot. And these kind of practices and analysis are really what allowed us to target the problems that we really needed to solve and build a product that did actually solve the problems that artists were facing. So all this said and done, we were really able to build this feedback loop in which both the researchers and the artists were finally happy with the results that we were producing. And the takeaway here is that this idea of fast feedback was really important to us. And not only being able to get reviews by artists and integrate them into our feedback loop, but also using Weights and Bias to automatically tell us which shots should be reviewed by artists and flag shots that we should be focusing on as researchers. So I'm happy to say that we have some pretty good key results now. Behind here are just some of the shows that we have actually worked on. I won't mention who in each of them, but various beauty fixes have been applied across these. In total, we have worked on 26 projects to date, which for clients, this is approximately 50% cost savings overall. And in general, from our benchmarks, the process of using Vanity AI over traditional workflows is about 320 times faster. And in total, we've saved about $8 million to date. And although beauty may not seem like the coolest project to be solving, it really allows these clients to focus on other effects and divest their money and time from these less desirable things that are really just for consistency or beauty fixes, and focus more on the cool effects that we all want to see, like dragons and spaceships and things like that.